See, the students, when they are in third year, they come across pure mathematics, that is abstract algebra, real analysis, linear algebra, complex analysis, and so on. So, if the students' reaction towards pure mathematics is like this, then this video is for you. Now, to transit from easy mathematics to rigorous mathematics, that is, in the first and second years, you would have done problems by just using one of the various formulae, whichever is suitable for that particular problem, then you use it and you solve it. So, from that easy mathematics, now if we have to prove some of the concepts which you have done only with the numbers, you have to do the theory behind them, or you have to learn the theory behind them. Then you must definitely know the techniques of learning that mathematics, that is your pure mathematics. Now, what is mathematics? Mathematics is the language in which God has written the universe. So, this is the quote from Galileo Galilei. And now, is mathematics truly a language? Yes. Mathematics is a universal language. The symbols and organization to form equations are the same in every country of the world. Now, what must a language have? So, we have already said that a language, mathematics is a language. Now, what must a language have? A language must have vocabulary, grammar, and syntax. So, mathematics has its own unique vocabulary, grammar, and syntax. So, these are the essential for communicating mathematical concepts effectively. Now, vocabulary, grammar, and syntax, what that are needed for abstract algebra, and of course, you can use them for linear algebra also. They are discussed in this video. Now, as for vocabulary is concerned, we must at least know numbers, operations, relations, functions, algebraic terms, set theory. So, as for numbers are concerned, we have integers, which is written like this. We need to have, you should not just simply put z, but that double line should be there. And for rational numbers, q with this double line, and real numbers r with the double line, and complex numbers should be denoted like this. Now, the operations, addition, subtraction, multiplication, in some cases we'll be using dot, in some cases this cross, star, or even composition of mappings, that small circle, all that we'll be using. Of course, exponentiation, square root, and so on. Now, relations, as for relations are concerned, equality. So, when you say that a number is equal to another number, or a term is equal to another term, so that equality symbol that you use. And inequality, when they are not the same, you use inequality. Similarly, greater than, less than, greater than or equal to, less than or equal to, all these you are already familiar with. And here in abstract algebra, you'll come across this new symbol, that is tilde, that is usually used to say whenever A is an element that is related to another element B, then that is symbolically written as A tilde B. And another concept or another relation that we use between sets is subset. And whether an element belongs to a set, that is usually denoted by belongs to this symbol. And this is used to denote when an element does not belong to a set. And you will later know what is meant by this congruence relation and isomorphic relation and so on. And linear function, quadratic function, exponential, logarithmic, and trigonometric functions, you have already come across them in your lower classes. Variable, coefficient, constant, expression, equation, and inequality, these algebraic terms also you would have come across already. Now, in set theory, mainly we have union, intersection, subset, complement, element, set. So these are some of the vocabulary that we need to have in case of set theory. Then grammar. So we must know how to write the rules and how to write in the case of English language or in Tamil language. We have grammar to write any sentence. So likewise, to write any statement, we need to have grammar. Not only just vocabulary, that's enough to do theory in pure mathematics. So we need to have all these also. That is order of operation. Uh, as we wish, we cannot write the parentheses or exponents and so on. So when you consider multiplication and division, it has to be done from left to right, and addition and subtraction again from left to right. And we must have an eye on proper usage of symbols such as plus, minus, say m times n. If you want to represent all that, we must be familiar with. And these symbols we have already said. And the function notation, that f of x, g of x, h of x, and so on. But in Hurston, topics in algebra by Ian Hurston, at the beginning and all, the notation to have this f of x, it would have been sigma and tau, those mappings you would have used. So x tau, x sigma, like that you can see in Hurston book. But in real analysis, when they use these functions, this is how they write. Meaning wise, it is the same. It is only the notational difference that you will find, but otherwise the meaning is definitely the same. Now, quantifiers, like existential quantifier, there exist, and for each or for all. So these universal quantifier and existential quantifier, they will be used quite often in abstract algebra, even in real analysis too. Now, proof techniques, already we have discussed. There are various proof techniques: direct proof, proof by contradiction, proof by interdiction, proof by induction, and so on. So there, when we prove, we will be using these symbols to denote if something is given, then something follows, means implies. And for biconditional, we use if and only if this symbol. Then syntax. Coming to syntax, you may have statements to be correct, but whether it fits into the context, that's very important. So that syntax is very important, and whether they represent the statement, whatever you are giving, whatever you want to have in proving a theorem, the statements that you give, that should be correct. So that comes under your syntax. So equalities, inequalities, equations like ax plus b equal to c, a and b, c, they are all coefficients. Here you can call it as they are all constants and x is variable. So when you write equation in standard mathematical notation, care should be taken. And in graphical representation, plotting points. When you write any point, we call it as ordered pair. It has got meaning. So suppose you have 2, 3, if you want to represent, you'll have to have along the x-axis 2 units, along the y-axis 3 units. So that you can represent that point 2, 3. That in that order. You cannot write, you cannot plot for 2, 3, the point 3, 2. That order matters. So then these drawing lines, curves, and shapes and coordinate axis, all of them can be had in linear algebra. When we discuss the concept parallelly, the graphical representation will help us. And algebraic manipulation, simplifying expressions, solving equations, factoring, and expanding. So again, it depends on the context, because when you have a set of linear equations, you know that it can be represented in a matrix form, ax equal to b. Suppose we have 3 equations in 3 unknowns, then capital A denotes your coefficient matrix, and the x is the unknowns x, y, z, and b is the constant, the what you have on the right side of the equations. So in that, to find the rank of A, you cannot use column operations there. You need to have only row operations. So the context is very much, it should be born in your mind that you cannot go away from the context. So usually when you find the rank of a matrix, both column and row operations are allowed to simplify the given matrix and to find the rank easily. But so that syntax plays a role there. Then this set builder notation, that is in many of the theory part in both abstract algebra as well as linear algebra, you need to have the collection of those elements which satisfy certain property. So that must be represented in this way. Okay. So to transit from easy mathematics to rigorous mathematics, you can go through this PDF, Basic Concepts of Mathematics by Elias Zakon. This is the website address, and it will be mentioned in the description box also. Now, we need to learn to read and write mathematics in words and using symbols also. Now, there is a concept called homomorphism, where here G and G prime, they denote groups, because between two algebraic structures, if you have a mapping, you can check for the homomorphism, that is whether the structure is preserved. So that can be checked. So if phi from G to G prime is a homomorphism, then kernel phi. See, if we read this as such, this is how we will read. All those element x in G that are mapped onto identity element, that is all those x in G for which phi of x is 0 prime. So this is as such when you read it. But when you read it in words, you can read it as kernel of a homomorphism phi is all those elements whose image under phi is the identity element of the codomain. So here domain is a group, codomain is also a group. So identity element will be present there in the codomain. So you can read this expression as such: kernel phi is set of all x in G such that phi of x is 0 prime. But in words means kernel phi is all those elements which are mapped onto the identity element of the codomain. And in the same way, if you have such an expression, then how would you read this one? So in this C of closed interval 0, 1 is nothing but the set of all continuous function, real valued continuous function defined on the closed interval 0, 1. C of closed interval 0, 1 is the set of all real valued continuous function defined on the closed interval 0, 1. So in symbols, you must be able to visualize this when it is read in words or when it is spelled in words. Now on this GPTC rule, as already explained in one of the videos, what is given, what is to be proved, and the technique involved, and the conclusion. So having learned the basics, what all mentioned earlier, now we will just see what is meant by this GPTC in the case of making upma, say, one of the tiffin of the South Indian houses, common, it's a staple food. We have to make upma, say, you are given suji, rava, and see the very basic items only I have mentioned here: mustard seeds, salt, and frying pan, of course stove, and oil. So these are the ingredients. So this is what is meant by what is given to us. So these ingredients, without them, we cannot make upma. So what is needed, what is to be proved is I need to make upma, right? Now, what is here technique? Technique is the recipe, the instructions for cooking this rava upma. So unless you know this technique correctly, you cannot conclude what is your aim as this. You cannot conclude the same. So if the instruction, if you go wrong, then you may have the dish to be like this and not what is expected. So we should not forget the rule GPTC to learn or to reproduce our mathematical theorems. So having all this in our mind, we can have our um, pure mathematics to be an interesting one. Thank you.